This
Class,
conference will now be recorded.
I would like to finish it bitwise operators, right? So I just given some question to you all. So you should practice number system conversions, right? Okay, I think there is some issue in a GoToMeeting. That's a problem. You are unable to join the session. Okay, and fine. So my last class, it was a bitwise operators. I need to be started, but I was given some assignment to you all. So have you gone through that conversion from decimal number to binary number system, binary to decimal number system? Is there any questions about number system conversions?
No, sir.
No.
No, right? So let's open the document. I just give some questions to you all. Okay, so I mean within now 2 minutes we can try to be resolve it. Okay, so I need the answers within a span of time, guys. So don't waste much time to give the answer for this small questions. I think I given a entire day to practice the number system conversions. So I'm just giving a small question to you all, and we can try to be answer it. For example, if you have a number is 67, so this is my decimal number. So I want the binary number for this one. Can we answer for these questions? Speed.
Yes, sir. I'm calculating it. Give me a second.
Everyone, I need the answer from everyone. So please send me your messages only for me, not to everyone. Okay, in the GoToMeeting chat. Harika and Revant not yet joined. Please rectify your answer. That's not correct. 67.
No, it's 1000011.
Sorry, I was in mute. Sorry for inconvenience. So whatever the number you have it, that number you're trying to be division with 2, then you're getting the reminders. The reminders, it could be either 0 or 1 only. So we just need to be collect from the, so this is my this is my first bit, this is my last bit. Okay, fine. Krishna, Krishna, decimal to binary is enough, Krishna. Okay, anyway, no problem. Okay, for example, if we have a number is 0b, it's my binary number. So 1100101101. So for this particular binary number, I want the decimal number. So answer it. Answer it. Speed up. Answer, guys. Eight one three. Is it?
813.
So this position is one position. This is 2. This is 4. This is 8. This is 16. This is 32. This is 64. This is 128. This is 256. It's a 512, right? So 512 position, 256 position, 32 position, 8 position, 4 position, 1 position. When you sum of it, whatever you are getting, that could be the result. Is it correct? So 10,
Yes.
18, 19, and 4, 23. So 8, 8 plus 3, 11. So 813. So absolutely correct. It's 813. Okay. So this is the way, if you have a number, so that number you can easily convert from the decimal to binary and binary to decimal, right? If you know this thing, you can easily solve it any bitwise operator. Otherwise, it's very tough to understand. Okay. So let me try to do small example. Before we do that example, I can execute some bitwise operators in the computer or in Python program. Then we can see how we are getting that result. Okay. Hindi headache వస్తుంది.
Okay, sir, I'll have to drop now.
Yeah, you can drop, Smita. You can go ahead your Scrum meeting. Okay.
Thank you.
So just go to your Okay. Okay. So go to your file. Okay. So now, so bitwise operators are, there are 6 bitwise operators are there. Bitwise operators. Okay. So when goes to the bitwise operator, there are 6 bitwise operators are there. The first one is bitwise AND operator. Bitwise AND operator. To performing the bitwise AND operator, we can use the ampersand symbol. And the second one is bitwise OR. We can have the OR symbol. Third one is bitwise XOR. Then we can use the cap symbol. And fourth one is bitwise NOT operator. Then we can use negation symbol. Okay. And so bitwise left shift operator we have it, right shift operator we have it. Left shift could be the two less than symbols. Right shift operator we have the two greater than symbols. Okay. So these are the right shift. Okay, so these are the 6 operators we have it in bitwise operators. These are all operators are working on the bits only. Okay, let me try with bitwise AND operator. Bitwise AND operator. Okay, so the number it is, for example, 56 AND operator with and 45. Okay, so we are getting the result is 50, right? So how you are getting this result? Can anyone answer this particular question? See, I already told you, in case of Python or in case of bitwise operators, so which is operating on the 2 numbers, right? Here 45 is my number 1 and 56 is my number 2, right? So first, these are the numbers I have to be converting to the binary number. So this is the things will happening in internally. So, and finally we are getting the output is the decimal. But what happens in backend? So this is the binary number. Okay, so this 45 you should be converting into the binary and 56 you should be converting into the binary. Then after, you have to be performing the AND operation. You know what exactly the AND operation is doing, and we should do the AND operation on the bits. So here we are getting the result is binary. That particular result of the binary you should be converting into the decimal. Okay, this is the pipeline of the working with bitwise operations. So now tell me, what is the value of the 56 and what is the value of 45? Tell me, what is the binary value of the 56? Is it correct? 111 000, right?
Yes, sir.
Okay, so what is the value of 45? Yes, this is the value of the 45, right? So the 56, this is the binary value of the 56. This is the value of the 45. So this step is completed. Now we should do the operation on the each and every bit. You already know the what is the truth table of the AND operator. If and only if two inputs are the 1, then output is the 1. If any one of the input is 0, then output is 0, right? So here we can do this particular 0 AND operator with 1. So one number is a 0, one digit is 0, so output automatically is 0 only. Two numbers are 0, so that it's a 0. Here one number is 0, so that automatically it's a 0. Here both are 1, so that it could be the 1. Here both are 0, sorry, both are, one is a 1 and second one is a 0, so that it's a 0. Both are 1, so that it could be the 1. So here 1 0 1 111. So now this is my binary result, right? This step is also completed. So this is the step you should be converting into the decimal number. How should you convert the decimal number? This is the position 1, this is position 2, this position is 4, this is position is 8, this position is 16, this position is 32. Only 32 position and 8 position numbers are 1, so that 32 plus 8, it could be the 40. Clear?
Yes, sir.
Is it clear? So this is happened. This is the output of the bitwise onto operator. So you can go ahead with any example. The process will be same thing, but automatically the Python will be taking care about it. But so what is happening internally, if you want to know it, then that could be the process actually. Okay, so you should remember that process. But most of the time we are not going to be using this one, and in any area only embedded engineers are working on it. So now we'll go and work with OR operator. If you go and work with OR operator, then we can use the OR symbol. So here OR symbol. So if it is the OR symbol, okay, so it's a binary bitwise OR operation, right? So first step is what? Conversion 56 into binary, 45 into binary. After that one, we should be performing the OR operation. So any one of the input is 1, then output is 1. So 1, and here it is 0, here it is a 0, here it is here it is the 1, here it is the 1, here it is the 1, right? So this is 1 position, this is 2, this is 4, this is 8, this is 16, this is 32. So 32 position, 16 position, 8 position, and 1 position are ones. So when you are sum of these all things, might you are getting the 57. Okay, so it's 57 or 60?
61.
Something is missing. $56 is it
45 binary is 101101, sir.
10110, right?
01.
So this is correct, right? Yeah. So this is 56, this is 45. Okay. And this is 1, this is 0, this is 1, and this is 1, and this could be the 1, this is also 1. Now tell me. 1, 2, 4, 8, 16, 32. So sum 32 plus 16, 48, 48 plus 8, 56, 56 plus 4, 60, 60 plus 1, 61, right? So this is the way AND operator will, OR operator will work in the back end. So next one is, we can try to do it XOR operation. So XOR operation means we can use the cap symbol, right? So cap symbol means here the truth table of the XOR operator is quite different than the AND operator and OR operator. So either if the both inputs are same, then output it could be the 0. Okay, 0 if the input is 0 and second input is also 0, then output is a 0 only. Or else if input is 1 is the 0, input 1 is the 1 and input 2 is also 1, then this situation also it could be the 0 only. The output is the 0 when the both inputs are same. So if in case any one of the input is different, then output it automatically a 1. Okay, here 1 and this is 0, so that we are getting the result is 1. So this is the logic we need to remember it. So when you are doing the XOR operation, so 56, 45, right? This is 56, this is 45. So 1, 0, this is 1, this is also 0, this is 1, and this is 0. So 1, 0, 101. So this is 1 position, this is 2 position, this is 4, this is 8, and this is 16, this is 32. So 16 position is 1, 4 position is 1, 1 position is 1. So that it's a 21 is the result. Is it correct or not? We'll check. If I execute this one, we'll be getting the 21 only. I hope you clear my point. Any questions? Any questions on these three operations?
No, sir.
No. No, fine. Now, bitwise not operator will look in the last. So before that one, we can try to work with right shift operator, left shift operator. Left shift operator. So left shift operator, we can use the number. That here we have a number, and you should shift towards left side some bits, number of bits. Okay. So that means that entire number you should shift towards left side some number of bits actually. So for example, if we have a number is 45, and you should shift towards 3 times. So which meaning is first what you should do, this is the number you should be converting into the binary. So 1101, this is my binary number. Okay, basically my computer is 64-bit computer, so that other than this 6, so there are 58 zeros you should add at right side. Okay, and now this is my actually 45, it could be stored in the computer in such a way. So now what I want to do, that I want to shift towards the 3 bits actually. That means this 3 bits. Okay, so 3 times you want to shift it, right? So first time this is the bit will be belongs to here, this bit is here, and 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 this bit is here. Okay, and in this particular bit position you should add the 10. So rest of the bits will be, it would be the 0, and the last 63rd bit we have it, right, that it could be truncated, this could be the truncated, and this is the 0 will be here. Okay, so this is fine. So you want to shift like this 3 times, right? 3 times, right? So second time also. So now this 0 here, this one is here, and this 0 is here, and this one is here, and this one is here, this 0 is here, and this one is here, and this 0 is here, and this 0 is here, and this 0 is here, and so on. Okay, and this 0 is here, and this is the 0 will be truncated. Okay, so here it is empty space, so that you should add the 0. Next one is like this, you want to shift to 3 times, right? Now the third time, when it is the third time, so this position is empty, but this positional bit could be here, and this is here, and this is here, and this is here. Okay, this is here, and this is here, and this is here, and this is here, and rest of the things would be it's 0. Okay, and last could be, it could be truncated. So here you should add the 0. So this is the my binary number, right? So my resultant binary number, what it is, 000 10 11 01, some number of zeros. Let me consider like this. Okay, so I want to be convert this number into the binary, so decimal. This position is 1 position, this position is 2, this position is 4, this position is 8, this position is 16, this position is 32, this position is 64, this position is 128, this position is 256. So that we have to do it 256 plus 64 plus 32 plus 8 plus 8, right? So what is the result? Tell me. 20, 11, 16,
3.
360, right? Is it really 360 or not? We can execute and we'll let you know it. It says exactly 360. Yes or no? Did you got my point? What is happening in backend? I hope you understood. One more time, why we are getting 360? It's a, don't confuse yourself actually. Just take this number. It's a 45. The number 45 is, we can representing in a binary 101101, but it's just only 64 bits. But my computer is, it's a 64-bit computer, so that rest of the bits, instead of the empty, it's zeros. But we are not mentioning every time because of it's a little larger number. Okay, little larger number. This is fine. So these are all 58 zeros. Let me consider these are all 58 zeros. Okay, and now I want to shift to 3 times, right? First time, this positional bit corresponding this position bit, it could be the empty. This change it to here, this is shifted to here, and this is shifted to here, and this is shifted to here, this is shifted to here, this is shifted to here, and this is shifted to here, and this is shifted to here, like this, and this is the shifted to here. Okay, but what about this one? This could be truncated. So this positional bit, you should add the 0. Now like this, you want to do it 3 times, so that second time and third time you should repeat the same process. So now this positional bit, it could be the space, and this 0 could be here, and this 1 is here, and this 0 is here, this 1 is here, this 1 is here, this 0 is here, this 1 is here, and this 0 is here, and it is keep on going at until unless this is here, and this one, it could be truncated. Okay, now here we should add the 0. And now third time, this is the 0 here, this 0 is here, this 1 is here, and this 0 is here, this 1 is here, and this 1 is here, this 0 is here, this 1 is here. Okay, and rest of the things will be, it's 0, and the last one is here. This is the 0 can be truncated. Okay, and here you should add the 10 extra. So this entire number you should try to be converting into the decimal, then you will be getting the 360 only. I hope you clear, right?
Yes, sir.
Okay. Okay, now so the logic, one thing you need to remember for every time. So number, you are shifting towards some number of bit sign, then simply you can say this number into 2 power of number of bits minus 1. Let me see, is it correct or not? 45 into 2 power of how many bits? 3 bits, right? 3 so 360 number of bits. This is the formula you should remember. Okay, if you the length of the process, if you're trying to do it, it will be very tricky, and so that I'm giving the shortcut for this one. So this is the thing which is equal to the number, whatever the number you have it, that number, and how many bits we have it, that is as a 2 is a constant, power of 2 number of bits actually. Okay, number into 2 power of number of bits, so you can simply 45 into 2 power of 3. So power you can simply mention as like 2 stars, right? So you can simply mention like 2 stars, indicating that it's a number of bits. So this is the thing we should remember it. So meanwhile, a right shift. So right shift, it is very simple. So here it is the division operation can be work here. So the symbol is number, a right shift of number of bits. Okay, so for example, if you have a number is 45 only, the 45 you're shifting towards 2 times, then you're getting the result is 11, right? How you're getting the 11, now we can see. 45 means 01101, right? And you should add this some number of zeros, because of it's a computer, can be adding the 0 internally. This is the first position. So you want to shift towards right side 2 times. If you shifting first time, okay, this one can be truncated. So this one position can be added to here, and this 0 can be the first position, the 1 can be the second position, this 1 is here, and this 0 is here, this 1 is here, and This 0 is here and it is going on. The last it can be empty space, so you should add the 0. Okay. Now second time, for second time, this is the position can be truncated. So this is the position will be comes to here, and this position is comes to here. This position 0 comes to here. This is comes to here. This 0 comes to here, and this 0 comes to here, and so on. Okay. The last it could be the empty space, so that you should add the 0. So 1011 is my number. The number of this one is it's 11 only, so that we are getting the 11. Okay. But the same thing what you should do, we can performing which means that number per power of a number division by 2 power of number of bits. This is the formula, you can remember it. So which means that 45, okay, 2 power of number of bits are 2, right? So that we are getting the same result or not. So this is the formula also, it can be help you to remember to get the result of this one. Okay. Okay, so last but not least, bitwise not, negation of number. So for negation of number, it's a minus of number plus 1. I can tell you that okay, so negation of, so 12 is 13. Okay, see, simply we can try to apply this particular formula for getting this result. So negation of number, right? So your minus of number value is how much? It's a 12. 12 plus 1, how much? It's a 13. For example, if you apply the negation of minus 12, negation of minus 12, minus of minus 12 is the number plus 1, so that minus of minus 11, so you will be getting the 11 is the result when you're applying the minus of 12. So just need to remember that particular formula, so that it could be easy to understood that, or it could be easy to remember what could be the value of it. Okay, I hope you clear my point. So like this, we can performing the operations on the bits as well, not only the numbers. Any questions? If you have any question, please let me know. I hope you clear my point, and thank you so much guys for understanding this particular class, and I would like to upload this particular file into your Canvas playlist. In the meanwhile, I can upload the today recording as well. Any more questions, Disha? But don't think about these things, guys. It's a very simple thing, and it won't help you anymore actually. Okay, it's a very simple thing. It won't help you, but thing is that if you know, it's a better. Again, vice versa. Headache. Bye guys, see you.
Bye.